Welcome back to another lecture series on building materials and construction. The topic for today is mud architecture. I think it's a truly fascinating topic, and this presentation is designed to give you the background of all those aspects related to mud architecture. Earth construction techniques have known for 9,000 years. Earth was used as the building material in all ancient cultures, not only for homes but for religious buildings as well. Many centuries ago, in dry climatic zones where wood is scarce, construction techniques were developed in which buildings were covered with mud. As you find here in the image, in nearly all hot, arid and temperate climates, earth has always been the most prevalent building material. The 4,000-year-old Great Wall of China was originally built solely of rammed earth. Only a later covering of stones and bricks gave it the appearance of a stone wall. Remember guys, the total length of wall is 21,196 kilometers. Whereas the country India measures only 3,214 kilometers from north to south. The core of the Sun Pyramid in Teotihuacan, Mexico, built between the 300 and 900 AD, consists of approximately 2 million tons of rammed earth. Now let's get started. There are several mud construction systems or techniques existing in different parts of the world, like cob, rammed earth, Adobe, Rattle and daub, compressed stabilized earth brick or CSEB. Usually in any district, probably only one way of making a wall is used. Obviously, one of the main objectives of these techniques is to make a wall at least the height of a man. Having reached that height, it must be capable of not only standing up but also of carrying the weight and thrust of a roof. Let's now get detail into the first system, the cob. The first, simplest and almost certainly the oldest system is called cob. This technique has been used a lot long ago in Europe, where it was named cob in England and beige in France. This technique is still used a lot in Africa, India and Saudi Arabia, where beautiful examples can be seen. Now just take a look at the image on the screen. The old historic capital of southern Yemen has been named the Manhattan of the desert. This place is the Shibam in Yemen. Shibam was recorded by UNESCO as World Heritage Site. In fact, Shibam was built with a combination of cob and Adobe. Next, we have the Masmak Fort at Saudi Arabia. This is a clay and mud brick fort with 4 watchtowers and a thick wall. Now, let's check the details of cob construction techniques. Here, plastic soil is usually formed in balls, which are freshly stacked upon each other. First, the mix of cob contains earth, water, straw and husk. First, mix these items. The straw should be distributed evenly. The mixed consistency should be regulated. If it is too dry, it will be tough to work on the wall, and if it is too wet, it shall bulge out. Now ram on the mix. Next, make cob balls and pass them to the wall. The balls should be of a size of 30 to 40 centimeters in length and 15 centimeters in diameter. A row of these cobs of mud are laid neatly side by side, preferably somewhat pressed together. Then another row of cobs is laid on the top. The second layer obviously lies in the depression between the lower rows of cobs. And though we build up in courses, we mix and merge them into the wall. Eventually, there will be no courses and no walls. Cobbers have to look out for corners and the verticality of the wall. We must use our hands wisely. One checks the corner and the other maintains verticality. It's really simple to rectify the errors. When it is tapering, just add more cob, and when it is bulging, simply chop off the extra fat. Another point to be noted: never hit a wet cob wall to level a budge. We can use a bamboo strip to poke the fresh cob and sew the straw into the wall below. With the help of extra straw and bamboo strips, we can create shelves and contours. Adobes are precast molded earth, while cob is inside stacked earth. Adobe is an agglomeration of units, whereas cob is a monolithic entity. So a cob wall will be stronger than an adobe wall due to the lack of joints and distribution of reinforcement. Cob, being a plastic medium, is limited only to our imagination. There can be seamless transition between diverse elements. We could also expose some objects to create beautiful and interesting patterns and textures. We can also embed glass panes directly into the cob to have fixed windows of any shape, as you find here on the screen. And the same is true for fixed louvers and grills of all kinds. Door and window frames can be attached to the wall by embedding porcupine blocks during construction. These act like holdfast. We can span these openings by corbelling cob balls or even by casting a monolithic cob arch. The plinth on which the cob wall is built can be kept jagged. This helps the wall to get a grip and sit down nice and tight. The roof can rest on the wall via beam or can be anchored by members embedded in the cob during construction. So now guys, let me briefly repeat the whole process of cob construction. First, with only a little water to form a very stiff mud, a large lump is roughly molded into the shape of a huge elongated egg. Secondly, the usual size is anything between 30 to 40 centimeters in length and about 15 centimeters in diameter. Third, a row of these cobs of mud are laid neatly side by side, preferably somewhat pressed together. Then another row of cobs is laid on the top. When 3 or 4 courses have been laid one above the other, the sides are smoothed over so that holes and cracks disappear. Openings for doors and windows are a problem, which can be solved by using temporary vertical planks or shuttering. So these are samples of modern cob houses constructed across wall. Now let's move on to the next system of mud construction. It's the rammed earth. On all five continents, rammed earth has been well known for centuries as a traditional wall construction technique. In fact, rammed earth foundations found in Assyria date back as far as 5000 BC. With rammed earth techniques, moist earth is poured into a formwork in layers of 15 centimeters thick and then compacted by ramming. Traditional rammed earth techniques are still used in many developing countries. Refined formwork systems and electrical or pneumatic ramming reduces labor input significantly and makes rammed earth technique relevant in some industrial countries as well. What you find on screen is the Atlas region in Morocco. The High Atlas is the largest mountain range in North Africa. The traditional mud brick city, which is on the UNESCO Heritage List, has been featured in a number of films, often as Jerusalem. Now on screen you can find a place known as Spiti. It's a cold desert mountain valley located high in the Himalayas, in the northeastern part of Indian state of Himachal Pradesh. The name Spiti means the middle land, that is the land between Tibet and India. The worldwide traditions of rammed earth construction has shown that it is possible to achieve long-lasting and majestic buildings from single to multi-story. One can find numerous and wonderful examples like farms and rural houses, villages in North Africa, parts of Great Wall of China, buildings in Himalayas and regions of Tibet and Bhutan, and of course in South Africa. Rammed earth employs volatile compression and goes something like this. We pour some moist earth in a box, and then we compact it with a hammer. We hit it. We repeat this in layers until the box is full. Then off with the box. These are the instruments and the materials used in the technique. First, the mix. Second, the rammer. Third, the formwork. Now the mix. The mix. The mix used for rammed earth is unlike most other techniques. It's almost dry. We sprinkle water that's just enough to moisten the earth. Such that a handful when pressed forms a ball that doesn't wet the palm. And the ball, when drawn from a couple of feet, breaks into a few distinct pieces. If the ball stays intact on being drawn, the mix is too wet. And if it gets shattered to smithereens, it's too dry. It's good to have a well-graded mix. It's very important to have a thoroughly homogeneous mixture. Mix dry, then mix wet, and then remix before you use the earth mix. Now the rammer. The earth mix can now be compacted with the help of a rammer, which is simply a weight with a handle. It's really easy to make your own rammer. Always think of the user's height and weight before making one. Now the formwork. Here's a traditional wooden formwork that's simple and convenient to use. It consists of planks, side faces, tie members and struts. There are so many ways in which we can play with the rammed earth elements. Ideally, you would need three basic kinds of formwork for three situations. First, a straight wall. Second, a L formwork for corners. Third, a T formwork for three-way junction. But you could also use a straight formwork and stagger the layers like masonry units. So here we have the sequence of rammed earth construction process. First, the human earth is poured in form of thin layers and then rammed to increase its density. Two parallel planks are held firmly apart by metal rods and clips or bolts, or by small cross pieces of wood. Stiff mud is thrown in between these two planks and rammed down with either a wood or metal ramrod. When one cross section is completed and hard, the two bolts are removed along and the process is repeated. So here, additional layers of moist earth are added and compressed. The two planks are then raised up and the second course of rammed earth is repeated over the first. Once dry, the formwork is removed to reveal the rammed earth wall. So that's about the sequence of process. Next we have the modern rammed earth techniques. In this system, soil stabilization gave a great input to rammed earth as well as mechanization. The traditional wood rammer has been replaced by pneumatic rammers. Heavy wooden formwork evolved into light composite ones made of plywood, steel or sometimes aluminium. Pneumatic rammers, dumpy loaders, mixers, bank conveyors, etc. allowed to build faster and get a better quality finish. Structures are most of the time built with pivots, meaning that walls are built up to their full height. This way of building changed totally the design pattern of structures. So here we have a modern structure built out of rammed earth. In fact, this is a porcelain museum in China. It's called the San Peng Art Museum. This is a modern building typology constructed out of rammed earth. This is a great part of housing in Australia. Now let's move on to the next system of mud construction. It's the Adobe. It's known all over the world as Adobe. Here in India, we know it as sun-dried bricks. This is probably the most popular form of mud walling because the mud blocks or bricks can be made by anyone and after drying they can be stored until there are enough of them and the right time to build has come. Now take a look at the image on screen. The Adobe is the largest Adobe building in the world, located in Bam, a city in the southeast Iran. It's listed by UNESCO as a part of the World Heritage Site, Bam and its cultural landscape. The entire building was a large fortress containing the citadel. The image displayed on screen is that of Taos Pueblo. It's an ancient community settlement of the Native American tribe of Puebloan people. It lies about 1 mile north of the modern city of Taos, New Mexico. This has been designated as UNESCO World Heritage Site. Initially, all Taos Pueblo walls were constructed using balls of Adobe. Later, they introduced the technique of formed mud brick. This technique revolutionized Adobe construction in the world. Now this one is the Great Mosque of Chennai. The Great Mosque of Jannah is a large Banco or Adobe building that's considered by many architects to be one of the greatest achievements of the Sudano-Sahelian architecture style. The mosque is located in the city of Janneh, Mali, on the floodplain of the river Bani. The walls of the Great Mosque are made of sun-baked bricks called furi and sand and earth-based mortar. It's coated with a plaster which gives the building its smooth, sculpted look. Now let's check into the Adobe construction techniques. An Adobe is a sun-dried brick, and it's really simple to make them. Mix earth and water, add husk, nail some wooden pieces to make a mold. Now throw the mix inside, press with your fingers and level the tops. Lift the mold up and now the Adobe slides out. Then dry up in the sun. Turn to a side for even drying. Wet the mold before you check the mix in. The mix has to be just the right consistency. Too wet and it will sludge. Too dry and it will refuse to come out of the mold. Here are a few types of Adobes. Adobe can be also hand-shaped, multi-mold shape, or even cut like cookies. The glue that we use to stick Adobes together is the mud mortar. We use the same Adobe earth for the mortar. Just add some extra water to the Adobe mix. That's all. The mortar is applied wherever two Adobe faces meet, between courses and between neighbors. Wet the top of Adobes. Spread the mud mortar. Place the Adobe firmly over the joint beneath. Mortar the neighboring face. Firmly place the next Adobe. The wall can now be mud plastered and painted. Doors and windows. Frames can be embedded directly into the Adobe wall and anchored with holdfast, which are inserted between courses. Next we have the foundation. Trenches should be dug wherever the walls are to be built. Adobe walls should be raised off the ground with a plinth. Next we have the roof. The roof should sit on a beam which distributes the load over the entire wall. So that's about the construction process of Adobe. Now let me brief you once again. So Adobe is known as sun-dried bricks in India. A small box or mold of wood or metal is used and the stiff clay is squeezed into the mold and then turned out to cure and slowly dry. After that, a mason can use them in much the way as he would use burnt bricks or cement blocks. The Adobe bricks can be made to any size. If care is taken to dry the bricks slowly, and if the walls are built in the normal proper way, strong crack-free walls are normal and can be used for 2 or even 3-story houses. Of course, care must be taken to protect them from wet and to use standard bonding patterns. So here are the advantages of using Adobe for construction. First, the raw materials are easily available. Second, the cost of manufacture is very less. The buildings constructed out of Adobe are cooler in summer and hotter in winter. And finally, we have cost savings in energy production. And there are few disadvantages as well. First, Damage can be caused by external forces such as wind, water, and earthquakes. Second, problems caused by excess of humidity or rainwater. Third, it needs regular maintenance. Fourth one, there are chances of cracking of walls in summer. So these are the disadvantages of using Adobe for construction. We can find numerous modern structures constructed out of Adobe. So this one is a mosque designed by architect Hassan Fathy in Egypt. It's known as the New Gona Mosque. Next we have an Egyptian market designed by the same architect at Paris. So it's a Paris market. Now let's move on to the next system of mud construction. It's the Rattle and Daub. It's very common in areas like Assam, northeastern states, parts of West Bengal, the Andaman Islands, that is, where bamboo can grow freely and plentifully. It has also been extensively used in many parts of the world, in developing countries as well as in Europe. As you can find here in the image, the village huts at Janale in Somalia are constructed out of wattle and daub. Again, few buildings of Alsace region in France are constructed out of the same system. Alsace is a historical region in northeastern France. Now let's get into the detail of this construction technique. So wattle is the skeleton. It provides structure to this union. Mostly, if not always, it will be of botanical origins. The material used to wattle varies with the context. Reeds, branches, fronds, bamboo, twigs, and stem can all be used. The earthen flesh covering on wattle is known as daub. This offers protection to the wattle and also provides stiffness. Earth and water are the base of the daub. Additives such as cow dung, ash, lime, plant juices, husk or fibers are often added. There are umpteen possibilities when wattle and daub come together. For example, if we split a bamboo in 10 strips, these strips can be organized in two ways. A woven system will be structurally superior to a layered one. Wattle and daub is meant for infill panels in frame structures and not for load-bearing walls. But these panels also need protection from these elements. Appropriate overhangs or temporary buffer screen surface. Even if some of the daub comes off, the structure is unharmed. Simply give it another coat of daub and it's as good as new. Again, let me briefly explain the process. Wattle and daub method is an old and common method of building mud structures. They are bamboo and cane frame structure that supports the roof. Mud is plastered over this mesh of bamboo cane and straws. Due to excessive rainfall, the wattle and daub structures gets washed off. However, the mesh of cane or split bamboo remains intact, and after the heavy rain is over, the mud is plastered again. Now let's look at the climatic response of wattle and daub. Usually, the frame structure supports the roof. Sometimes, excessive of cyclonic winds would dash dry rain against the walls. However wide the roof overhang is, ordinary solid mud structures collapse and the mud from wattle and daub structures gets washed off. However, the structure itself
and the mesh of cane or split bamboo remains intact, and after the heavy rain is over, the mud is plastered on again. The same sort of rectifiable damage also occurs when there are earth tremors. Even the framework of wooden post sometimes is thrown out of the vertical but does not collapse and can usually be pushed and pulled back into proper shape. Now let's look at some of the features of Rattle Dog. Regarding thermal insulation, it's warm in winter and cool in summer. And regarding the humidity, Rattle Dog provides a comfortable environment year-round, and it is earthquake resilient.
Rattle daub is still used for the construction of modern structures, but in a slightly different way. As you can find here in the image, Casa Munita is a house in Chile. One of the central elements of the house is the round earth wall made with clays of different colors. But here they have used steel mesh instead of bamboo wattle. Another structure is Casa in Aruda in Portugal. Here they have used industrial materials like asphalt, concrete, polycarbonate in combination with natural materials like wood, earth and stone. This house is an interesting example of sustainable practice.
Now let's move on to the next system of mud construction. It's a compressed stabilized earth blocks. So compressed stabilized earth blocks, CSEB, commonly called as pressed earth blocks, are construction material made using damp soil under high amount of pressure to form blocks. They are composed of dry inorganic subsoil, non-expansive clay, aggregates and Portland cement. CSDBs are an environmental friendly alternative to clay blocks that most of the residential construction in India today uses.
It's a development from traditional rammed earth. It seems that the first attempts at the compressed earth blocks were tried in France in the first years of the 19th century. The architect Mr. Francois Cointrox tried around 1803 to precast small blocks of rammed earth. He used hand rammers to compress humid soil into small molds which were held with the feet. As you can find here on the screen, Sri Karneshwara Nadaraja Temple at Tamil Nadu was constructed out of CSEB. And these apartments at Colombia designed by architect Mauricio Sanchez are constructed out of CSEB.
Now just look at the construction process of CSEB.
The soil, raw or stabilized, is slightly moistened and poured into a steel press and then compressed either with a manual or motorized press. CSEB can be compressed in many different shapes and sizes. The input of soil stabilization allowed people to build higher with thinner walls, which have a much better compressive strength and water resistance. With cement stabilization, the blocks must be cured for 4 weeks after manufacturing. After this, they can dry freely and be used like common bricks with a soil cement stabilized mortar. Compressed earth blocks are most of the times stabilized and shown in the examples hereafter. Hence, we prefer to name them compressed stabilized earth blocks.
Now just look at the soil suitability and stabilization for CSEB. A soil is an earth concrete, and a good soil for CSEB is more sandy than clay. It has these proportions. It consists of 15% of gravel, 50% of sand, 15% of silt and 20% of clay.
topsoils and organic soils must not be used. Identifying the properties of a soil is essential to perform. Another point to be noted: soil stabilization is the alteration of soils to enhance their physical properties. Stabilization can increase the strength of a soil, thus improving the load-bearing capacity. Here we can find few advantages of using CSCBs. First, it's inexpensive and energy efficient. Second, it has high structural strength. Third, and top of that, it's toxin free. Fourth, it's biodegradable. It's soundproof and resistant to fire and pest. And it does well with aesthetics and adaptability. It also helps in reducing deforestation. Further, CSCB manufacturing can provide employment opportunities to people while inculcating social values in them. However, there are some limitations for CSCB. First, it's not suitable for high-rise buildings and wide spans. Second, proper soil identification is required prior to the construction process. Third, skilled labor is required. Fourth, it requires quality check at every stage of manufacturing to avoid low-quality products. Now guys, that's all about the few techniques on mud architecture. The links to other construction videos are provided below this video. Hope you enjoyed this presentation. Bye for now and we'll continue in the next lecture. Please like and subscribe my channel.